Hello everyone, welcome to the session. So now in this video, we will be starting our very first part where we will try to understand the data. Okay. So the very first thing is that we need to install the required packages, which are really required to do the complete step of understanding the data. Now, because we are doing it in Google Colab, there is no specific need to do the manual installation. Everything is by default installed in this platform. Okay. But at any point of time, if let's say you are doing in your local system, so you have to manually install the packages required first. For that, I'm writing a command which you have to use. So the very first step is to install all the required packages or the libraries that we need. For that, the command is pip install. For example, let's say we are using NumPy, so you need to install it. Okay? In the upcoming sessions, I'll try to talk about the complete end-to-end pipeline in a Visual Studio where we will try to create a separate requirements.txt file where usually we used to write these libraries, and then there is one command pip install requirements.txt which we usually write, so that every particular library will be installed in one go rather than doing it one by one. But as of now, because it's the very first project that we are covering up in this particular project module, machine learning module, so take it very easy and we will try to do it in the Google Colab itself. So as of now, just consider that you have to do it for whatever libraries we required. Okay, for example, NumPy, Pandas, Matplotlib, Seaborn, and so on. Now the second important step, obviously we are skipping this step because we are doing it in a collab. The second important step is to import all the required libraries. So we need to import that. Perfect. So let's import this. So what we will do is we will say import pandas as pd, import numpy as np. Then we need import seaborn as sns. Then we need import matplotlib.pyplot as plt. And in this way, we will be able to import all the required libraries. In the second step, what we will do is, usually what happened is, in the upcoming sessions, obviously we will take some dataset outside the, real time or from Kaggle, from various different platforms. But as of now, again, because we are starting, in the sklearn itself, we have by default lot many datasets to analyze to perform the task. So we are taking the data of this house price prediction from there itself. So we need to load the dataset. Okay? And the dataset that we are using is a California housing. So I'll directly load that data of a California housing. So what I will do is I will say from sklearn.dataset, as I told you, from there itself a lot many datasets are available. And from that, what dataset we need to import? We need to import fetch underscore California underscore housing, right? Now what we will do, we will say housing is equals to fetch underscore California underscore housing. So what we will be able to get is a complete set of data available for a California housing. Let's try to see this type of this housing data that we have. You will observe that this belongs to a sklearn.bunch kind of a data set. It's a dictionary, similar to dictionary based data, but not exactly the same. It's a data set which contains key value pairs itself with the metadata available for a given data. So if I just try to show you this data set rather than talking about a lot, here if we will be able to see, we will be having a key as data, and then we will be having a set of data points. Similarly, we have target, which is obviously a house price value. Similarly, we will be having a frame, target names, feature names, and so on. Similarly, we have description, which indicates a description of each and every attribute that we have in a given data. So if let's say I want to show you the description value of each and every data available in this housing data set, so we can clearly see that here if you will be able to observe, we will be having 20,640 number of instances. It means the size of the data is also not that small. It's a very big data, not very big, but yeah, moderate size data is there, where you will be able to see 8 numeric values are there, predictive attributes are there, and the target value is there. So here if you will be able to see each and every variable or the feature name that we have in a given data set, the complete explanation is given to us. For example, med inc. Obviously, via this variable, we will not able to get an idea what this variable indicates. So this definition is given that it's a median income available in a block group. Similarly, house age, it's a median house age in a block group. Average rooms, average number of rooms per household. Average bedrooms, average number of bedrooms per household. Population, block group population is available. Average occupation, average number of household members. Latitude, block group latitude. Longitude, block group longitude. So it means that blockwise, the feature values of income, house age, number of rooms, number of bedrooms, population, and so on, features are available to us. And on the basis of that, what we want is finally we want to predict the price of the house. That's the real target that we want to achieve. So here, if you will be able to see, if we will say print housing dot feature underscore names, so we can print that list of names, that feature values that we have in a given data set. Similarly, if let's say we want to see what are the what is the target value maybe which is available here, so you can clearly check that. You can say housing dot target, and here you will be able to see a list of all the given records house prices, right? 20,000 something records are there, right? So for every particular record, what is the house price available, that is provided to us. Okay. So similarly, if let's say I want to see the data, so what I can do, I can say housing dot data. It's a 2D kind of an array which is available. So again, here if you will be able to see, data is available where for every attribute, what is the value being available, it is there. So in this way, we will be able to see the complete, I would say, data set, the description of a data set. I hope you will be able to understand this data, and you will be also able to understand the problem statement pretty well, that we will be having the attributes or the features correspond to every feature. We will be having a target number, which is a, you can say, price of that particular house depending upon the house age, number of bedrooms, number of what are the values that we have, right? We have studied number of rooms per household, house age, income, and so on, right? So in the upcoming session, what we will do now is, in the next important step in the pipeline is that how we can prepare the data. That is the next important step. For the preparation of the data, as you can see that as of now, this is a sklearn bunch kind of a data type that we have. What we have to do is, first of all, we need to convert this data into data frame so that we can apply operations on top of that. We can do a EDA task on top of that, right? Exploratory data analysis. After that, we can do a model training on top of that. So step by step, in every video, I will try to explain each and every step in a great detail. So please stay tuned. I hope that until so far you will be able to get my point, whatever I want to deliver it here. With this, let's end today's video. I'll see you all in the upcoming session, where now we will talk about the data preparation part, where I'll show you how we can convert, first of all, this data into data frame, and then how we can perform the further task on top of that. With this, bye-bye everyone, and see ya.